All right, welcome back. We've been talking about loops in this unit, and as you might imagine, there's some, AP, CSP stuff that goes with loops. We looked at pseudocode, right, with Unit 2 on a few things, and as we had some visuals on like logic gates and that sort of thing. There's also visuals when it comes to our flowcharts. And so we're going to take a look at that. This designing a flowchart, we're not going to quite do that. That was a hands-on thing, and we're not very hands-on at the moment. So there's an oval that indicates the beginning or end of your program or your loop, right? And it's just a simple start or end. There's the arrow, that's something else you'll see that shows kind of the direction of flow, what you should move to next based on your current position. And that could change based on some type of decision point. The parallelogram shows some type of input or output of a program, right? Maybe we're getting something from the user or we're printing to the console. The rectangle is some type of logic, right? Here in this example, we're actually seeing that sum is changing or just a simple increment I. The rhombus is where we're going to see key decisions. Okay, so we'll come into it, it'll have some type of decision, and we can either, in most cases, go left or right. So here's an overview of everything, and I'm kind of speeding past most of this because I think the example is going to be the best explanation for all this. Take a look. On the left-hand side, I have kind of a generic idea about how if statements work. We're going to encounter our if condition, and if the condition is true, maybe go this way. Right? It should be labeled which direction. I'm not necessarily saying that true is always on the left, that sort of thing. Keep in mind this is supposed to be loose. This is basically a visual representation of the pseudocode. So if it's true, we'll go to the left and execute those statements. If it's false, we'll go to the right and execute those statements. Regardless, after we exit the if statement, we will continue on with our program. So take a look. In the actual example, we say if x is less than or equal to 16, we're going to print lower. Maybe there should be a parallelogram. Otherwise, if that's false, we're going to print higher, and then we would continue on. Okay, that idea can be expanded to some type of loop here. This is the start of our program. We have some type of initialization. You'll quickly see over here in our example, we're declaring some variables and giving them values. We encounter our condition, and if it's true, we'll execute some statements, maybe adjust our counter variable with the increment, and then come back up and check our condition. We're going to keep doing that loop part until our condition is false, at which point we could do more things after the loop before our program ends. Here in this example, we're starting here. We're going to create I and x, both are 0. And it says while I is less than or equal to 20. Okay, I'm going to add 1 to x. I'm then going to add 1 to I. And I'm going to come back up and check the condition. At this point, I is 1. And so I'm going to ask, is 1 less than or equal to 20? Well, that's true. We're going to increment x, increment I. We're going to keep doing this like 20, 21 times. Eventually, I is going to hit 21, at which point we would ask, is 21 less than or equal to 20? That is false, and we would print the final value of x before our program ends. Okay, so with that in mind, let's actually get a real example. All right, some type of practice problem. Here's the start of our program. We want to know, is I equal to 2? I'm sorry, we're going to initialize I to 2. We then encounter our condition, and it's asking, is I less than or equal to 6? That is true, so we would print I plus 1. We then increment I by 2. We're going to keep doing this a couple of times. So let's take a look at what we got going on here. We're at the start of our program. We've established I. We're going to ask, is I less than or equal to 6? That is 2 less than or equal to 6? That's true. So we're going to come down. We will print I plus 1, which puts a 3 in the console. We're going to come over here. We will increment I by 2 effectively, right? I is now 4. We're going to check the condition. I is 4 at this point. We would ask, is 4 less than or equal to 6? That is true. We're going to enter the body effectively. We're going to print I plus 1. So 5 shows up in our console. We're going to come over here and adjust I. I is now 6. That's the end of that iteration. We're going to check our condition again. We're going to ask, is I less than or equal to 6? At this point, yeah. That's true. We're going to print I plus 1, so a 7 shows up in our console. We'll come over here, increment I by 2. I is now 8. That's the end of the iteration. We'll come back up and check our condition again. Is I less than or equal to 6? Is 8 less than or equal to 6? That is false, and you see with the flow of our program, we're going to come over here, and we ultimately end up stopping. So this is ultimately what is displayed, and you could see this being kind of a test question where you don't necessarily need to know loops, right? You can just kind of follow the flow chart, okay? That's going to be it for the flowchart loops thing. There is pseudocode to cover, pseudocode on both loops and random. Let's check that out real fast. So there's a couple of loops, and they all mimic our Java loops in some way. The repeat loop is basically going to be like a while loop. The code in the block of statements is executed n times. Right? So we're going to repeat n times. Actually, this is more like our for loop. Right? An example of this would be just 10. Right? We're not really keeping track of a counter variable. This is just going to happen 10 times. In this particular example, we're displaying hello world, effectively printing it. Keep in mind, this is all pseudocode stuff. So this is the pseudocode version of system.out.println. Okay, there's also the repeat until loop. This is the one that's more like the while loop. The code and block of statements is repeated until the Boolean expression condition evaluates to true. So the bit of a problem I have with this is the logic here is slightly inverted from the traditional while loop. Okay, so we're going to repeat until this becomes true. The way that our traditional while loop works is it repeat a condition until it becomes false. So this is slightly inverted and maybe something you need to be careful about. Here I have an example where we're saving 7 into X. Notice no data type. A reminder that pseudocode is dynamically typed. You don't need data types. We are going to keep looping until X is equal to 1. Okay, well initially we're going to basically ask the question, is 7 equal to 10? I think I just said 1. Is 7 equal to 10? That is false. So we have an iteration, right, where we're going to increment X by 1. X is now 8. Is it 10 now? No, it's 9. Is it 10 now? No, it's 10. Is it 10 now? Yes. That's the point at which we would stop. Okay. The last little pseudocode thing we have to talk about is random. Random evaluates to a random integer from A to B, including A and B. Here's an example of it. Okay. I do like this one. It's a little bit easier to use than the random that we are used to, that we've been working with. Simply put, the numbers that you provide here is the number range, right? There's no real extreme manipulation. It's 1 inclusive, 3 inclusive. That easy, right? This is going to give you a random number within that range, and we could, of course, see it by displaying it if we wanted to. Okay, that's it for our pseudocode. So you're going to check Canvas for a packet that has kind of questions related to this pseudocode stuff, and knock that out. I'll see you in the next video.